Hi everyone, and welcome to the week 6 session 2 class. And just like always, it has been amazing. Everyone has been doing great, and we're almost coming to the end of the Cairo Bootcamp. But there's of course still more to come because we have a $1,000 bounty for the build week. So if you have been active throughout the bootcamp, you should get ready for the build week because it's going to be amazing. You're going to have some winners at the end of the day because the aim of this bootcamp is to get people to start building on Starknet and also get very active. And today we have, just as always, we have Casweeney join us to go more in depth into smart contract testing. Without wasting our time, let me allow Casweeney to dive straight in.
All right. GM, everyone. Can you hear me? Can you hear me? All right. So we are ready to fire down. And so we are going to be doing a lot of debugging today. So what I want to do, in our last class, I mentioned that I was going to give an assignment where you guys will complete the ERC20 test. Well, because we couldn't finish, so I'm going to finish the ERC20 test. Then your assignment will be to write test for the token sale contract we already done before. So that's what we are going to do. And let me share my screen so that we get started. Okay, share screen. Desktop one. Yeah. So can you see my screen, guys? Yeah. Okay, sure. All right, let's get to business. Document. No, not document, desktop. Yeah. So this is it. We were here. Yes, 20 OZ components. Yeah. Has a RC20 contract. So in our last class, we had the bug. So I left the code the way where we stopped. I've not done anything on it. So we are going to continue from there. We are going to look for a way to fix the problem, and we'll debug and fix the bug and all of that. So yeah, this class looks like it's not going to be very long. Well, let's see how it goes. All right. So I'm going to zoom in. 1, 2. That's too big. That's way too big. Okay. So um also we know that Scarp takes quite some time before it does its magic. So we are going to be waiting for Scarp in many cases. So I'm going to do Scarp test so that we ascertain that we were at the same place we stopped in the last class. So Scarp test, let's wait for it. So I think I might, okay, let's just wait for this guy. I'm sure it's gonna move faster. Otherwise, maybe I need to close some applications. This guy eats memory. Okay, it's quite fast. Now, okay. All right. So we are still at the same place we stopped. It's saying entry point selector not found. So remember what I said in the other class that one of the features of integration tests is that it's harder to debug because we are interacting with 1, 2, 3 functions. So we don't know the exact one that is causing this error, right? So we need to start commenting and uncommenting to figure out where the problem is actually coming from. So we are going to first comment all the asserts, right? Then I'm going to comment the total supply as well to see if that's where the problem is coming from. So I'll run my test again. So what we are learning now, uh, for those of you that probably don't know how to debug, this is another way for you to learn debugging, right? So this is how to debug. Time. All right. So the problem is not from total supply. See, we have commented out total supply here, but we are still having that same problem. So what we are going to do now, we are going to comment out balance of and see everywhere we have balance of, we are going to comment it out and see if it's coming from balance of. So we run our test again. I think for every time you run scab, it's like it's compounding the memory usage. So the more you run it, the more it eats up your memory. So let's wait for it. All right, we got the error again. So that means the problem is not coming from balance of, then it should be mint. So let's comment out mint and run the test again and see if it's still going to throw that error. Okay, let's see. Okay, so you see that the test passed now. That means the problem is coming from the mint, right? It's coming from the mint. Now let's now check what's happening. So our interface here is public. Let's look at this guy. Our interface here is not public. Okay, let's make it public and see. Oh, yeah, our interface here is not public. So I've made it public and let's run the test again. So I want to, for every change I make, I want to check if that's where the problem is coming from so that we're able to, okay, check if your main function in the interface returns Boolean value. If so, then return true after the mint. No, that's not where the problem is coming. This is the interface trait in the contract. This is the interface now. Oh, yeah. Oh, yes, thank you. So we do hash Starknet interface. Oh, how I missed that. Yeah. But let this guy finish running. Let's be sure. Yeah, that's true. Thank you, Chigozim David. Okay, sorry. That's not even it. Let's uncomment this guy back so we are sure where the problem is coming from. So I'll uncomment all of this. So I'll open up all the asserts, right? So now we have added the interface the interface stuff in the contract. So let's run the test again. Scab. Let's see if that's where the problem is coming from. We are going to find it though. We are going to find it. But could this be the problem? I don't think so. I honestly don't think so though. But let's see. Okay. Scab, page me fast. Okay, that's not where the problem is coming from. So let's scroll down and see. Yes, that is it. That is it. That is where the problem is coming from. You know, since remember that it is that ABI embed 0 that makes everything inside this implementation visible, like externally visible. So that is the reason why it's failing. So I'm going to do ABI into embed underscore v0, right? So are you guys enjoying this? You see how we are debugging, right? So let's go. Let's check it out again. Let's check it out. Okay. So it's saying the feature I'm using is deprecated. Sorry, I don't know the update. So if any of you know the updated this contract, well, I'll check it out later though. Okay, this passed now. So the problem was line 38. The problem was line 38 actually. And with this, Chiagozium? With this, Chiagozium has won $25 worth of stack tokens. Clap for him, clap for him, clap for him. He's the one that gave us the solution. And he gave the first one, it wasn't correct. He also gave the second one. So $25 worth of stack tokens. All right, so we good. Let's proceed. Yeah, you guys should be active. So now you see that we have been able to test this guy. So in this total supply, we also tested mint. So will it make sense for us to test mint again? Hello? Should we test mint again? Because we have already tested mint inside total supply. If this mint didn't work, this total supply wouldn't have worked. Then there's something I was having issues with in our last class. Let me check it again. I think my compiler was very slow. My compiler was very slow in the last class because I know that stuff was supposed to work, right? That stuff was supposed to work. So I did something in the last class. I did something here. I said, let token under decimal be equal to this guy dot decimals, right? This guy dot decimal. And here I now said, let mint amount be equal to this times decimal, token decimal dot into. This is what I did. And you see, my compiler is fast today. You see, this guy it's no longer throwing that error. The same error it was throwing in the last class. So sometimes this compiler can make you think what you're writing is rubbish. Yeah, because in the last class, the compiler was taking time to compile the whole code, and it looks as if maybe this stuff wasn't working. So this is it. And this is just saying, what's it called? 1,000 times 18 zeros, that's times 18. So yeah, so this is it. So this is the test. I was asking, do we need to test mint again since we already used mint inside the total supply? Is there need to still test mint? If you guys want us to test mint, we can go ahead and test it, but we already tested mint inside here, or let's just test it. Let's just test mint. It's the same thing, because if you want to still test mint, you will still check the total supply again to ensure that the total supply has increased. So it's just you're repeating the same test. So there's no need to test mint. Let's move to approve. So the next test we are going to write the test for approve. And let's proceed. So we are going to say test, right? So I can just call this test total supply and mint, so that this test total supply, it tests mint and it also tests balance of. Yeah, test total supply, mint, and balance of. But let's just leave it like that so that the name of the test won't be very long. So what we want to test now is FN test approve, right? Yeah. Okay. So now, how do we test approve? So to test approve, before you write test, you need to first of all understand how the flow will look like. So to test approve, that means you're going to work with two addresses, right? So you're going to first mint to one address. When you mint to one address, you now prank that address that you minted to approve another address to spend that token. Then you now check the allowance of that, or you check the allowance of the address that was approved to check if it increased and all of that. So that's how we are going to test the approve. So in this test, we are going to see how to prank an address, to make an address to be the one calling a particular function. You know, if from the Solidity side, they call it prank. You start prank and you prank a particular address. So we are going to see how to do that in Starknet, in Cairo, and all of that. So that's the next thing we are going to do. So there are some things that we are going to still use. We are going to use this guy. We are going to deploy the token here. We are going to get the token here and all. So the next thing we are going to do, we are going to mint. So let's create two addresses. I'm going to create an address called, this is the owner address, and I'm going to create another address called recipient. So these are two addresses, owner and recipient. So what I'm going to do, let me get a mint amount. So let me get token decimal. So I'll get token decimal here, and I'll get mint amount here, right? I'll get mint amount here. So, and let's create an approve amount. Let's approve underscore amount be equal to, let's say approve amount is 100, right? 100 U256, 256, right? Times, just pick this guy and paste it again to avoid typing over and over again. So our approve amount is 100. Our mint amount is 1,000. So we want to mint to the owner. This is the address of the owner, right? We want to mint to that guy. So I'll now call this guy. I'll say this token, right? What is this? Pick this guy, copy. I'll say this token dot mint. I want to mint to, our mint takes what first? Our mint takes the address first before the amount. So I want to mint to owner first. Mint owner to owner. Then I want to mint amount to the owner, right? So once I do this, I want to also ensure that the balance of the owner is equal to mint amount. Let me just pick this guy here. So you're able to test every step. This is very good so that you're able to track this guy. So assert that this token dot balance of owner is equal to mint amount. Else you say mint failed. So this is done. Now, once we do this, the next thing we want to do now, we want to approve, right? We want to approve. But the person that is going to do the approval is this owner. This is the person that is going to do the approval, not, you don't just approve. The owner is the one that has the token. So you want this owner to approve this recipient, right? So there's something you need to do. They call it start cheat caller address. So you need to import it. Let's import that start cheat caller address. I think it's here. So when I say Starknet Foundry gives you like helper tools like that you use out of the box, this is one of them. So start cheat caller address, is it here? This compiler should respect itself. Oh, it's not here, it's not here. This is not where you get it. It's not where you pick it from. Think you pick it from the Starknet Foundry standard library, SN Forge standard library. So it will be here, to be in this SN Forge standard library, not inside Starknet. So you pick it from here and you do this guy. So you see it works there, right? All right. So what you do now is you're going to, let me just put a comment here. Now, make owner the caller. So I'll now come here, I'll paste this guy here. Once I paste this guy here, what I want to do now, I want to pass in the contract address that we want to call in that prank. So it is the token address we want to call. Then the next thing, who am I pranking? I am pranking owner. So the owner is the person I want to prank, right? And I'll end this. So below this guy now, I will now say ERC20 token dot approve. Now, this call that I'm making here is being done by this owner. That is what this thing means. So who do we want to approve? What does the approve function looks like? The approve function takes in the address you want to approve, and it also takes in the amount you're approving. So we are approving the recipient, right? I'm going to pass this guy here. And we want to approve that the recipient can only spend the approval amount. So I'm going to paste this guy here, right? What is happening? What is happening? What is happening? What is happening? Okay, that's the compiler problem. So once we do this, we need to stop this cheat caller. If not, every other thing below it will be affected by that cheat caller. So you need to do stop underscore. So just copy this guy, this same guy, just paste it here. But this time, remove the start, change it to stop, S-T-O-P, stop, right? And now you want to pass in, so you're passing in the contract address, not the address of the recipient or the person that you're pranking. So we are stopping cheat caller, but we have not imported this, right? So let's bring it in. Let's bring it in. So this is it. Now we are good. So let's now do our assert. So I'll just copy this assert here, bring it down. I'll now say, how do we test for this? I'll now say assert that your security token dot allowance, right? Allowance of owner. So allowance takes in the address of the person, the actual owner of the token. Then it takes in the address of the person that you're allowing. So check that allowance of this is equal to approved amount. So we want to be sure that this person was actually allowed to spend this approved amount. So if it we say approval fail, right? Right. Then you can now do something called sanity check. I just say assert that it is greater than 0. So let's say wrong approval value, right? So why I'm changing this error message is so that I'm able to trace where this test is failing in case the test fails. All right, so this is what happens here. We first deploy our contract here. After that, we connect it with the interface. For this case, we are using dispatcher. Then we get our decimal, which we are using to multiply with the amount so that we get an actual amount, times E18 for the Solidity guys. And our approval amount is 100. So we create 2 dummy addresses, owner and recipient. We mint some tokens to the owner and assert that the owner balance has increased by the mint amount we used. Then we now prank the owner and make sure that the owner approves this recipient to spend this approved amount on the behalf. We stop the prank here, and we are now checking if the approval actually worked. And the way to check if approval works, if you were approved, is using the allowance function. So you pass in the actual owner of the token and the person that was approved to spend that token. And that is what is happening here. So any question before we run our test? Any question? Okay, no question. Let's run our test then. So I'm going to say scab test. Why do I feel like I'm already done with this class and we are not even 1 hour into the class? I have to look for something else to do. Okay. Okay, let's run our test and see why the test is running. Let me look for something else that we could do. Yeah, they are randomly inserted addresses. You could use anything, actually. I just copied any address. I'm not testing for events. Well, let's see. Let's see how it goes. Okay, so our test passed, right? Can you see it? The test passed. So just to check if the test will fail. So we are going to use mint amount here instead of approve amount. So let me show you guys something, but let's run this test first. So the reason why we are using try into here, you see that we are specifying that the type we are passing here is a contract address. But this stuff you're seeing here, the Cairo compiler is going to see this as a failed. It's going to see this as failed. So when you use try into, you're saying it should try converting this stuff to a contract address. And anytime you use try into, you're trying, which means it's going to return okay or error. So, and whenever something is returning okay or error, you need to use unwrap to handle it. So unwrap, what unwrap does is, if it returns okay, unwrap will return the value straight up for you. But if it returns error, unwrap will panic. That is why you're using this stuff and all. Yeah. So you see that the test failed. And the reason why it failed, it said, let's see if it say approval failed. And let's see the line, see this message, approval failed. Let's see where it's telling you approval failed here. Because the amount that was approved is not equal to mint amount, but approval amount. So our test is working as we expect it to work. All right. So before I proceed, I wanted to show you guys something quickly. Yeah. So let me quickly show you guys something. For those of you that want to explore more, this is my GitHub, and you can see this repo here called Awesome Starknet Cairo. Anytime maybe I mention something that you do something, it's something I've done, I've tested it, and I know how it works, right? So if you open this guy, you see that I've written a couple of smart contracts and with Cairo, and I wrote tests for them, right? So these are different contracts I've written. Even this ERC20 we are doing now, this is it, ERC20 components, ERC1155, ERC721 with OpenZeppelin and all of that. So you can, for those of you that want to know how to test for events, it's here. If you check this test, let's see, there is a place where I tested for events here. Let's look at it. I don't know if it's here. So I tested for events in one of these guys. Maybe it's not here. So, but you can see tests. These are like complex tests and all of that. So this is not why I tested for events. I think in one of these guys, I tested for events. Let me check. So I think maybe, could it be in Piggy Savings tests? Let's see if I tested for events here. Yeah. This constructor, this deposit, start as spotted. I didn't test for events yet. So, but one of those contracts I tested for events, I think 1 or 3 or so, I can't remember, but I tested for events in a couple of them. So what I'm saying is, you can play around, you can check this repo, you see most of the, let's see multi-sig. Maybe it was here I tested for events. Or probably because I'm scrolling, I'm not seeing this guy. It's not here. So let's just continue. So you can check this out. These are different contracts I've written, and I wrote tests for almost all of them. So you can check them, use them to practice and all. It's in those practices that you become very hardcore with writing Cairo smart contracts. So with that out of the way, let's continue with what we are doing. So now we are done with this guy. We are going to write tests for the for the transfer function. So let me see what you guys are writing. Is there a reason why we are not using assert macro for equality comparison? Sometimes assert EQ, this. Is there a reason why we are not using the assert macro for equality comparison? Something like assert EQ or let me see. Let's check. So this thing is basically the one that is you're more convenient with. Let me see if the assert EQ. Okay, the assert EQ is there. So let's check it out. Assert EQ. So you're asserting that, okay, this is not where we are asserting for EQ. We'll assert EQ on this one. On this one, yes. This guy, this is where we are asserting EQ. So assert EQ macro. Wait, let me be sure. Assert underscore EQ. Yeah. So now we want to assert that this guy is equal to this guy. So we are going to put our first comma here, put this guy. And why? Okay, so this one is expecting a string, not felt. So you are going to remove this guy and use double quotes. So, and this should work, right? This should work. Yeah, this should work. So it's the same thing. Whatever you're comfortable with, whatever you're comfortable with. Yeah, you can test for events in Cairo contracts. You can test for events. So let's run our test again. Scarp test. Let's see. That should pass. So it's the same thing, whatever you're comfortable with. Assert EQ, then asserting that this is equal to this is same thing. So Hamid, I don't know if I answered your question. All right, so let's wait for the test to pass or fail. All right, that test passed. So I want to check something. Let's assume we didn't prank this guy. Let's see what will happen if we didn't prank the owner, right? Let's see what's going to happen, right? If we didn't prank the owner and see if the test will still pass. Just to check whether the pranking is working, right? So let's still run our test. This is how you test, because you might run your test and it's passing, it might actually not be working. So you have to like remove some things to see if the test will fail, right? So let's see what's gonna happen here. So this test is expected to fail. And let's see. All right, it failed. And what is, say, wrong approval value? So most of the times when you see this wrong approval value, is basically the person that is approving doesn't have the amount they want to approve or something. I think something like that. I can't tell where this error is coming from. So let's see if, okay, yeah, this is where it's coming from. Yeah, from here, yes. This is where it's coming from. So it's coming from here. So we approved this guy to spend this amount, but the approval didn't work. That's why it's telling you wrong approval value. I'm expecting that the allowance of owner recipient is greater than 0, but the person that called this approve function is not the owner. So that approval will not work. The person that called this stuff is supposed to be get contract address. That is the person that called this stuff. This contract is the one that called that function. So if we do this guy here, if we do this, let's pick it up. Yeah, if we do this and remove this owner here, I'm expecting this test to pass, because if you didn't prank the owner to approve this guy, the person that is actually doing the approval is this contract. This contract is the one making that call. So let's try and see if it's going to work now. So you see that wait, failures, okay, as allowance. Well. How many tests do we have here? We have 3 tests. So one failed. Assertion, allowance, owner, approve amount, failed, approval, failed. Okay. Approve amount, 1,008. So this is not working. I think the reason why this is not working is because, let's see, assertion, there's a 20 allowance. There's no owner here again now, right? So owner recipient is equals to approve amounts, approval failed. Okay, failed. This one now is coming from ERC20 token itself. So this is ERC20 token allowance equals to 0. Approval amount is 18. So the approval amount is 18. That's 100 times 18, which is 18. Yeah, okay. So this error is coming from the token itself. Let me delete this terminal and open a new terminal so I'm sure of what's happening here. So let's see. When you're not pranking a caller and you're calling approve function, it is expected that it is the contract instance that is making that call. It is the contract instance that is making that call. So if the contract instance is the one making the call, then it is expected that the allowance, for you to check the allowance, you're using the address of the contract instance and the recipient that you're approving to check for that. Then, okay, I've seen it. It is this one that is failing, the last one, the one on line 91. That's what's failing, sorry. Yeah, Someone said it, I think it's coming from the last assertion. Yes, Hamid, yes, that's correct. It's coming from the last assertion. Yeah. So let's run this test again. So let's see what's happening. So everything should work now. Everything should work because this approve was called by this contract. So this is the contract address. It should work. If it doesn't work, then we have to look for where the problem is coming from. Is this supposed to be? No, we didn't do E18. We didn't do E18. So if we want to do E18, I'll show you how to do E18 in Cairo. We are just doing times the decimal. The decimal is 18. So 100 times 18 is not going to be, it's not that stuff, yeah. So you see that it's passing. It's passing. So that's because when you don't prank the owner, it is the contract instance that is making the call. And to get the address of the contract, you use this get contract address. So let's now revert back to our initial state, right? Yeah, this is how it works. So let me show you how to get E18 in Cairo. Thank you for bringing that up. That thing, so I struggled before learning that. I was working on a particular project on only Dust, and I was looking for a way to get E18 in Cairo. Like, I was asking, like, how do we get E18? And you have to hard code it. There's no shortcut to getting it. So I'll just show you that. I used it in, I think I used it in one of this code. Let's see, in staking rewards, yeah. It should be there. Let's check the test. Yeah, this is it. This is it. Const E18. Let me just copy it. So if you want to really use the whole E18 stuff, you just create this constant, call it one E18. So bring it in here where, yeah. So just keep it here. So pick it and remove this decimal, right? And just put it there, and you should be good. So with this, you have gotten your E18. I don't need decimal again here. And neither do I need it. This is total supply and mint, right? And I don't need decimal here again. I'll just use one E18, right? Just use one E18. So this is it. And we should be good. Let's run our test again and see. If the decimal is not it, I don't understand. What if the decimal is not 18? How can we handle that? So you can do I think is there I don't know, let me check if there's something like I'm just checking something. Let's check is equal to 10.pow 8. Is there pow? There's no pow. Okay, let's see if this is going to work. 10 star star 8. Will this work? This doesn't work. Let me see. Mismatch type. This is okay. Let's do 10 underscore U 256 resp of 8 underscore U 25256. Let's see if this is gonna work. So this is not working. I honestly don't. I'll check. Maybe you can check too. But I've not thought of a way to do terrorist power in Cairo. But these are the possible ways. I think in Rust we have power. In Rust we have power. We have 10 dot power. We have something like this in Rust. Yeah. But let's see what's saying here. Power is not found on type. Consider importing it, one of the traits. Oh, you can import it. Yeah. Oh, I see. You can import it actually. Yes, you can import it. Let me see. Use, right? Let's see. Will this work? Whoa, you do your research. Oh, this thing is not, it's not, I need to now find out how to now use this guy. I need to find out how to use this guy, right? So, but this is not how to use it. Let me see. No, traits, power, self, okay. Oh, self-based exponents. Apple self. Okay. Let's see. What is it saying? Is power supposed to be, is it supposed to be like this? I don't know. Hello, bro. This guy is not working. So we are going to check it out. Capital is, nah, it shouldn't be capital. All right, so that's by the way. Let's proceed. That's how to use 1E18. So you can research on how to raise things to the power in maybe in Cairo. I've not done it before. This is the first time I'm trying something like this, so maybe I'll check it out later. But for now, let's fire down. Okay. Let's now write test for our transfer function, right? So we are going to say test, right? The transfer function is going to look almost the same like, it's going to look almost the same like the approve function. So we are going to say fn test underscore transfer, right? And we are going to pick almost everything from the approve. So watch, guys, so you don't get confused. I'm picking almost everything from the approve. I'll copy it and paste it here. I don't need to type all of them. So what I'm going to do now, I'm just going to remove common. I need to crank this guy back. Yes. Yes, I need to crank this guy back. Right. So I'm going to remove all this assert here, right? Get rid of all this assert. So we have our mint amount. We have, let's call this transfer amount. Transfer amount. So this is the amount we want to transfer. This is the owner, this is the recipient. So we are minting to the owner first, mint amount, checking to ensure that the amount we minted is the same as the balance of what the owner has. Then we start cheat caller for the owner. So here we want to do transfer, and we want to transfer to the recipient, and we want to transfer this transfer amount, right? And this is it. And we are going to stop cheat caller here. So I'm going to now pick this assert, right? So I'm going to say assert that balance of remove this guy. Balance of recipient is equal to the transfer amount. It's equal to the transfer underscore amount, right? So else we say transfer field. That's one. What is that? Okay, yeah, that's one. Then the second thing we are going to do, we are going to assert that balance of owner. The balance of owner is equal to mint underscore amount minus transfer amount. So this should be the new balance of the owner because you have transferred. Why is this one train error here? This is the same thing now. Okay, yeah, we're good. So this is it. So we are checking that the balance of the recipient is now equal, sorry, not greater than, it's equal to, yeah, it's now equal to transfer amount. And the balance of the owner is now equal to the mint amount, which was the amount we minted to the owner minus the amount that was transferred. So we are now going to say wrong owner amount, right? Yep. All right, let's run our test. Scarp test. Are you guys following? Is this making sense? Yeah, you can use cheat span, but for the purpose of this stuff, I'm not using cheat span. When you start reading Starknet Foundry documentation, you see other cheat codes that are there and all of that. So you can explore them, see what they are doing, and how to use them and all of that. So whenever you're working, writing tests, there are certain things you want to do. You look for the cheat code that does that for you. There are some cases where I needed to spin the block.timestamp. So I spinned it. I'll show you why I manipulated block.timestamp in a test. So you see that we have written the test for transfer, the test for approve, the test for mint and total supply, the test for constructor, and everything is passing very well, right? So let me show you. There are so many cheat codes you can use. It's not in this class. I will now start showing you all of them. Look at this one here on line 96. You can see this one where you're pranking the block.timestamp and all of that. So there are many, and you have to stop the block.timestamp here as well. There are so many ways to, there are so many cheat codes and all. I'm looking for the cheat code where I'm looking for where I emitted an event. I just want to show you guys, we might not be writing it, we might not be writing that. I don't have a contract that is emitting an event. So I just want to show you, I did that in one of these stuffs I did. Let me see, where could it be? Where could that be? Sorry, a moment. It's not in staking. Testing Cairo contract. It should be here. It should be here. Yeah, it should be here. Testing Cairo contracts. Let's see. Aha, it is here. So this is the cheat code you use to test for events, spy events. Can you guys see my screen? Can you guys see my screen? Yeah. So this is what you use in testing for events. So let's look at it. This is constructor. This is test change owner should change owner. Should panic. This is if you want to test that something should panic, like when you want to expect revert in Solidity, it should revert if maybe the person is not owner. This is how you test for something, expecting something to panic or revert. And this is the revert message you're expecting, right? This is also another one. Only owner can make pizza. The same thing. Capturing events with spy events. So this is where you test for events. Yes. So you start your cheat caller. You turn on your spy events here. So this will listen for events. Then when you make the pizza, you now expect it. This is the event you're expecting. And you're now asserting that spy event, assert emitted this particular event. So you can check this out and see how to use it and all of that. So, but it's here. So that's why I told you guys, play around this repo. There are so many things you're going to be making use of here and all of that. So we are done with testing our ERC20 token. And since there's no other contract we are going to test, we are going to write a contract. So brace up, we are going to write a contract right now. A very simple contract. And when we are done writing it, is also going to, if time doesn't permit us to start writing the test, I'm going to add it to your test. So you're going to test it as well. So I'm going to close this one now. We don't need it anymore. So, but before we proceed, any question? Any question, guys, before we proceed? Okay, no question. All right, all right, all right. So let's move ahead. I'm going to close this guy now, right? And hmm. All right. So let's quickly play around something. Yeah. This is our guy. So I'm going to open a terminal here. So I'm going to say, let me maximize 1, 2, 1. Say scarp new bank, right? We are going to write a bank contract. So scarp new bank, create this guy, foundry. Yep. So I'm going to cd into bank, right? I'm going to open it. Yep. I'm closing this guy. Yep. So let's get to business. Yeah, I'm getting rid of this. So the first things first, we are going to all right. Hash into Starknet colon interface, right? So I'm going to say public traits are going to call this iBank, and this is going to take in T contract states, right? Inside this bank, we are going to have you're only doing two things with your bank. You're either depositing money in your bank or you're withdrawing money from your bank, right? Right? Okay, so that's what we want to do right now. So we're going to say, and both functions are going to be modifying state. So I'm going to say fn deposits, right? Shade, this is how they write it. FN deposits, ref self. And when you're depositing ref self, T contract states, right? You need to deposit an amount. So if when we are talking about depositing, we are actually talking about depositing tokens, right? We can write our contract in a way whereby you can deposit any kind of ERC20 token, and you can write it in a way whereby you can only deposit a particular ERC20 token. So which one should we write? They want to deposit a particular ERC20 or they want to deposit any? Any. Okay. All right. So if we are depositing any, that means we need to accept the address of the token we want to deposit. So that means we are going to have something like token underscore address, and we are going to have something like contract address, right? Then we now need to pass in the amount we want to deposit, which is a U256, right? This is not returning anything. It's not reading from state. And now we need to do use Starknet : contract address. Yep. All right. So let's withdraw. So for withdraw, we say FN withdraw, right? And we are saying ref self, same thing, T contract state. We need to pass in the actual token we want to withdraw, right? We need to specify the type, and we also need to pass in the amount we want to withdraw. Oh, I'm feeling good. It looks like I'm in my mood. All right, let's go. So now we have this guy. Let's write our contract. We are going to say Starknet : contract, right? And we are going to say mode bank. And this needs storage. So we are going to say in this guy, let's say storage, right? And inside here, we are going to say public struct, call it storage. Do we need to make it public? I don't think so, but does it hurt? No, it doesn't. So remove it until we need it. So now we have our storage, right? We are tracking tokens and their amount, and we want to be able to track users and we want to be able to track tokens, the amount, and users. So that means we want to track balance. And to track balance, we want to track the balance a particular address have for a particular token, which means we need something like, if it's in Solidity, we'll say something like, we need something like this address pointing to another mapping, right? Address, which will give you a U int 256. This is what we do normally in Solidity. So for Cairo, what we just need to do, we call this, what should we call it? Someone give me a name. We call it balances. Is there anything like balances? Balance, job. So we need something like map, right? We could do this. We could now say contract address, comma, we do another map, right? We now say contract address again, right? Comma, U256. We could do this, and this will work perfectly well. So I just need to bring in read storage and write storage, this thing. Let me copy it somewhere. I have where I can copy it. So I'll bring it here. They say I should use core again. I should just use Starknet straight up. Yes. Then I need to bring in contract address as well. So, like I said, we could do this and this will work. But there's something that Cairo and Rust have that Solidity doesn't have, which is like a way of using tuple. So what we are just trying to do, we are just trying to make this thing unique, whereby this key and this key, when you pass them, you're able to get this stuff. So there's no point doing this 2D mapping again. So you can just do something like tuple. Let me just show you what you can do, right? This is the map. You can now use tuple as your key. Remember before, in areas like Solidity, you can't use tuple as a key. You only use a specific type. But here, you can use tuple as your key. So inside that tuple, you now pass your combination, contract address, comma, contract address. So it's now going to return the U256. I don't know if this makes sense. So now this tuple is now your key. This thing is now your key. So this can be, just put a comment here, this can be owner to token address to amount. So this is what we are doing here. I don't know if you guys are following. Is it making sense? So now it will just be the tuple of this guy to amount, and that's all. So you don't need to do a 2D mapping again. If it was in Solidity, what you would do is owner mapping to token address that returns amount. So let me use the same thing for return here, right? That returns amount. But here you just use a tuple, owner and token address in that tuple, return this guy, and we are good. We don't need any other distinct. So with this now, we are done with our contract. We are done. We are so done with our contract. Very, very simple smart contract, as simple as ABC. So let's proceed. Let's now, what's the time? 7:21. Okay, let's fire down. So let's now implement IMPL, bank IMPL of super : what are we picking? iBank, right? Pass in your contract state here. Am I correct? Yes, I am. So this is it. So what you just need to do, pick these two guys, paste them here, right? Come here, open it, come down, come here as well, open it, come down, remove the T from this guy. We are no longer dealing with generic. Remove the T and we are good. So what we now need to do is to fill in these functions with what's important, right? All right. So the first things first, token and amounts. Let's do our checks because we are actually, right, this is DeFi. We're actually dealing with funds now, right? So let's assert. I like using, let's use felt. Let's assert because felt is cheaper than when you're using byte array. I think I have not confirmed that. It's not proven. But I just think coming from Solidity side of things, because strings cost more gas, so I feel felt to be cheaper. So let's just say, assert that amount is not equal to 0. Then you say 0 not allowed, right? 0 amount not allowed. So we could still do this. Let me show you the string ahead, correct? Let me show you the string equivalent of this. This is a string equivalent. Assert into this, right? Amount is not equal to 0. So for string, I'll use double quote. And here I can use the long text. You cannot pass in 0 as amount. If you use this long text in felt, it's going to throw error because felt has limited number of strings of characters you can use. So this is string, this is felt. The difference is this macro sign in front of it and this double quote. This one doesn't have macro and it's single quote. That's just it. All right. So let's fire down. So I'm going to get rid of this, right? So now assert that amount is not equal to 0. Now let's also assert that this token address is not an address 0, right? How do we use address 0 again? Let me look for it. I used it in one of the contract I wrote with you guys. Which contract was that? I used it in one of the contract I wrote with you guys, right? Let's see. Was it here? It should be in this no component. Let's check. It should be in this no component. Let's check. So I don't have all those things in my head. I just look for where, this is it. So this is it. Copy it. So I just bring it here. Right. So where did I use it? Let me check it out. Where did I use it? I used it somewhere now. I used it somewhere. Where is it? What color address? Oh, it's like I didn't use it though. Okay, this is it. Yeah, this is it. So what I just need to do is this guy. This is what I just need. Yeah. So I'll come here and say, assert that token address is not equal to this guy. And I'll say 0 address not allowed. So progress, we are moving. Let me get rid of this guy. Do I still need anything here that I might come back for? I don't need anything again. I have this one off head. I know this one. It's this one that I don't know. Okay. All right. So let's proceed. Now we have asserted, we have ensured that the amount this guy is passing is not 0, and the address they are passing as token address is not also a 0 address. Then what do we do? This is deposit, right? We are now going to say self dot balance, right? Dot entry. So dot entry, you now say entry is where you now passing the key. This is where you passing the key now inside your entry. Dot entry, you now passing your tuple as your key. What is our key? The first thing is the owner. Who is the owner? Get caller address. Let caller be equal to get underscore caller underscore address. That's the person that is making the call. So let's just import this guy here. Right? Bring it in. So that will be the first key. This caller is the first key. So pass it in as the first guy, comma, what is the second key? The token address. You pass it in, right? This is our key. Then you now do dot write. What are we writing? The amount. We are writing amount into that guy, and we are good. This we are done with our deposits. Are you guys following? Does it make sense? Yeah, I've not used that one before. So maybe it's a new guy in the blog and I've not used it. Maybe when I when I start writing new contract, I'll check those ones out. So this is it. Now let's play around events, right? Let's play around events. Let's see if we can emit an event. So let's emit an event. So what I'm going to do now, I'm going to put the event macro, right? Event. So I'm going to also put all these derive. These are some stuff you need to add, drop. You say Starknet event, right? So event is mostly an enum that is going to be an event, right? So inside here, we want to call it deposit sucks. Is it a spelling of successful? Successful, right? And it's going to be emitting a struct with values, also called deposit successful. So we are going to create that struct now, call it struct deposit successful. and it's going to have in, there seems to be a couple of ways to get it done. Okay. So now for the deposit successful, we want to pass in the address of the user. So we say for user, and it's going to be contract address, right? We also want to emit the token. So call it token address, and it's also of type contract address. And we will also want to emit the amount that the person deposited, and we also call it U256, right? Yeah. So now there are some stuff we need to mark on this guy to make it know that this is an event. Flag it with Starknet, event, right? We should be good. Compiler, please behave. Wait. Oh, this should also be derived into drop as well. Let's see if this works. What's happening here? It's like deposit successful, right? Deposit successful. Starknet events. I said Starknet. Yeah. So yeah, this is it. Why do you add pub to event attribute? Yeah, if you don't add pub to this event attribute, if you want to test it, you won't be able to test it because your test will not be seeing the event attributes. So everything in Cairo, the same way in Rust, everything is private until you add pub to it. And without pub in front of it, you can never access it outside. Does that make sense? Yes, it does. All right, let's proceed. Now, at the end of this guy, we need to emit our event, right? So let's emit our event. Whoa. There's a bug in this contract. Who can tell me the bug? There's a bug. Look at the deposit function. There's a bug. Hello? Is nobody seeing the bug? Exactly. We are not removing the token. So we just updated this guy's balance in the contract without actually transferring the token from the guy, which is not good. That's a very big bug. So what we need to do now, we need to get an interface, ERC20 interface, so that we can interact with an ERC20 token or something. So I'm going to create okay, let's create a folder, interfaces, right? Inside this interfaces folder, I'm going to say this contract is beginning to look big. I thought it's just going to be small contract. IERC20.Cairo, right? I'm just going to copy IERC20 interface and paste in there, right? So we are going to paste this IERC20 interface here, right? Then we need to expose this guy. So what we need to do now, we are going to create a file called interfaces with the same name as the folder .Cairo, right? So inside this file, we are now going to say public mode IERC ERC20, which is the name of this file here. So we are exposing it, right? So this is how we are exposing it. Then, to use it, we are going to bring it inside our lib. Inside our lib here, we are going to say use create interfaces. You are not removing the hair transfer from, yes. Create interfaces. This create. Oh, please, let me use the one that I'm comfortable with. Let's use bank interfaces. I did not see it. Wait. Oh. I need to bring it here. Public mode interfaces. Yeah. So let's check the other pattern we were using before. Create interfaces. Yeah. IRC20. Yeah. So we need the dispatcher. And anytime you get your dispatcher, you need your dispatcher traits. IRC20 dispatcher traits. All right. So we get that. So with this now, we can now interact with a deployed token. So what we need here is just say, let token be equal to this guy into contract. I like giving space into contract address colon. So it is this token now we want to interact with, this token address. So we put it here. So this is the token. Now, you now say, this is how you can just do token dot transfer from, right? You can do token dot transfer from. So you're transferring from caller. You are transferring from caller to get contract address. So you're transferring to this contract. So let me import this. Get contract address. Yeah. So you're transferring from this to get contract address. Compiler, what's up? Get contract address. Did I spell anything wrong? Get contract address. Yes, now this should be it. My compiler is beginning to misbehave. So get contract address, comma, amount. So you want to transfer this into this guy and you end the statement. So, but me, the way I like to do it is, I do this because we are dealing with funds. Let transfer be equal to this, right? And I'll now come here and say, assert again, assert transfer. Else I'll say transfer failed in peace. Failed in peace. Remove the in peace, just leave it transfer failed. All right. So this is how I normally write it. So save it and assert that the transfer works, right? So once that is done, you are now going to, once this is done, oh, you see the problem now. There's another bug. We are overwriting. We should be able to increment the balance, not override the balance. So let's do let previous balance be equal to, I'll just do this self.balance of this guy. So we are going to do self.balance.entry caller token address, but this time we are going to do read, and read doesn't take anything. So this is the previous balance, right? So now to update, we are going to do write previous balance plus amount. And this is the correct thing we are supposed to do. Are you guys following? Is there any confusion? I'm not going to write the test and I'm happy. You guys will write it. So I'm going to emit an event. In fact, this should be the assignment. I'm going to emit an event and you guys will write test to emit events. So you do your research very well. So, but are you guys following up to here? Does it make sense so far? Okay. Only one person. How many persons are on this call? Yeah. Okay. All right. So let's emit our event. So we have updated our balance here. Yeah, it's not technical. This thing is straightforward. It's just that, in fact, this is very, see now, let me tell you why I say Cairo is very sweet. Watch. Just take a look. Entry, you pass in your key and you're reading from the storage. This is just like English language. This is another one. You're passing in your key. Entry, this is your key. And you're writing and you pass in the value you're writing. This is just sweet and straightforward. It's not technical. It's straightforward. Solidity is not easier. Solidity is not easier. It's just that Solidity syntax is shorter. But this one is more intuitive. It's straightforward. Solidity that you write your code finish, I'll use your inline assembly and hack your money. You're telling me Solidity is. Let's proceed. So let's emit an event. So let's say self.emit, right? So self.emit, you open this guy. You now pass in, what do we want to emit? We want to emit deposit successful. This is what we want to emit. Now, when you open deposit successful, it has fields. So the fields now is what you're going to fill in. The user. So you now say user, and you pass in the value. Who is the user? The user is the caller, right? The next stuff is the token address. Token address. You do this, and you say token address, which is this guy, right? Then you do comma. You now say amount, which is also this amount, right? And you're good. You have emitted your event. But now, token address and token address are the same thing. Amount and amount are the same thing. There's no point doing this again. So just shorthand it, and you shorthand it, you're good. You see, this thing is very, you see this thing is very simple, like very straightforward. This one is calling Solidity OG. Okay. Oh. All right. So this guy is straightforward. Are you guys following? Is there anything you don't understand here? Okay, let's go to our withdraw function. This is 44 minutes, so we have like 4 plus 6, 50. 44 plus 6, 50 plus 10 on 60. That's, we have 16 minutes to go. All right. Okay. Let's finish the withdraw function. So withdraw. How do we withdraw? How do we withdraw? You check if the person has the amount they want to withdraw first. Okay, yeah, that should go. So we have this guy. We can still do our checks to ensure that they don't waste their money, right? So just ensure that the amount and the address they pass are, just do those checks again. Aside that amount is not 0 and this is not address 0, right? Let's get our caller as well. So we say caller, let's caller be equal to get underscore caller address. So this guy is good. So the first thing we want to do, we want to ensure that the guy that is calling this guy has enough money in this, that they have deposited money, because you cannot withdraw something you don't have, right? So let's check, let's caller balance be equal to self dot entry. There's a syntax, sorry, self dot balances. There's an old syntax in Cairo. I don't know if it still works, where you can do self dot this dot read, right? You can now pass in this guy as, let me see if that syntax still works though. Sorry, I'll say caller, comma, token address. I don't know if that syntax still works. Yeah, that syntax doesn't work again. So there's one syntax like that you can do this, but it's outdated, it's deprecated, it doesn't work anymore. So let's do dot entry. Let's use the new syntax. So it's here now, we now make use of our key. I'll pass it here. So this is going to read the balance of this guy. So let's assert that caller balance is greater than or equal to the amount they want to withdraw. Else you say insufficient balance, right? Right, yeah, this should work. So keep it here. Yes, this should work. This is just straightforward. This should work. So when we have ensured that this guy has the money they want to withdraw, what do we do next? We can, do we transfer before we deduct, or we deduct before we transfer? Guys, you're the ones writing this contract. It's not me. I'm not teaching you how to write contracts. Do we deduct before transfer, or we transfer before we deduct? Eh? Eh? All right, we deduct before we transfer, please. So we are going to do self dot balance dot entry. So let's get our key again. This is our key. Pick it. Pick this key. What we are now going to do now, dot write. What we want to write now is caller underscore balance minus the amount. That's what we are writing, right? Then, what is our token? We now say, let's, oh, yeah, the token. Let token be equal to ERC20 dispatcher into contract address, and this is the token we want to get. This guy, edit here. You can, so I like doing this, but you can as well just do dot transfer here, and you transfer to the caller and the amount. You can do this straight up in one line. Yeah, this should work. Why compiler? Why? See, it doesn't have main transfer. Why? Let me see. Why would you have transfer? This is transfer, yes. It does. Yeah, the compiler has fixed itself. So you can do this, just one line. Yeah, you can do this, right? So there's no need to say token, just call it transfer here. And you assert that this assert is not compulsory. It's not compulsory actually. It's not compulsory. Assert transfer, else you say transfer. Because normally if the transfer fails, this line will fail. But this is just how I like doing this, all these checks, please. Assert if you say transfer failed, right? So just do this. So you can do this, just run everything in one line. But I like, separating the token so that my contract is very readable. So I like doing token, then this will end here, right? Then I'll now say let transfer be equal to token dot transfer. So this is how I like writing it a lot of times. Sorry, token, not token address. This is how I like writing it a lot of times. So that you're able to see that, okay, here is where we are connecting and getting our token using the dispatcher. Then here is where we are transferring that token. So this way, everything looks clear, right? So we transfer from the guy. Let me see question. Why are you adding assert to verify, right? So you might choose not to add it. You can choose not to add it, but I like adding it. The thing is, even if you don't do this, let me show you. Even if you don't do this, if this transfer fails, this line is going to fail. It will not work by default. This line is going to fail. But me, I like adding it. I don't know why. It will not harm. It's just an extra check. I like adding it. So that's why I added it. Does it make sense? So, two of them said, question was, since the Cairo VM doesn't support delegate calls or fallback, which means reentrancy is not quite possible on Starknet. If I transfer before I deduct, what harm does it cause? Well, the thing is, coming from Solidity, where we know that a lot of things can go wrong, right? Please, I just like doing it like that for my own sanity. You get, I like doing it like that. Because, there's what we call, I don't know if this is, there's what we call retroactive inhibition and retroactive inhibition and retrospective inhibition. So this is when you've learned something before and you're learning a new thing, the knowledge you have in that thing you know before is now helping you take decisions in the new thing you're learning. That is what is happening here. My knowledge in Solidity is affecting the way I do things in Cairo. So even if Cairo VM doesn't, Casweeney, you have no love for Solidity. Are you whining me? I've written Solidity for 3 or 4 years. I like Solidity like mad. I like it so much. It's just that anytime I write Solidity, I need to look that code again with a second eye. Like, you are never sure of what you write until you look it again. That's one thing with Solidity. So you have to, Solidity is the reason why security auditors are making money. Because the contract is so unsafe, you have to be extra sure of what you're writing. That's the reason. So my Solidity knowledge and experience is what is affecting my decisions in Cairo. That's why I'm making sure the same steps even in back end, if you're writing back end, you have to deduct from the wallet before you transfer. Then if the transfer fails, that is when you now revert, you put the money back in the person's wallet. So that is normal standard security in software engineering. So it has nothing to do with maybe Cairo, solidity. Even in back end, that's how you do it. You deduct before you initiate the transfer process. So that's it. If not, there's something called, somebody can re-enter your function and all of that. So those extra checks just to be safe, just like a lady who got dumped by a guy, she will be very skeptical. This one don't carry heartbreak up. So let's continue. All right, so we have done our withdrawal. Let's create an event. We have 5 minutes, so let's create an event. I'll just duplicate this guy. So sorry, I'll just duplicate this guy. I'll call this withdraw successful. Withdraw successful. Copy it. Paste it here. Put a comma here. Then duplicate this guy as well. Right? Call this guy withdraw successful as well. Right? And withdraw successful, the user, the token amount, and all. So it's just the same thing. So all I'll just copy this guy here, and I'm going to emit it here. But this time I'll change it to withdraw successful, right? Yep. So the user is the caller, the token address, the amount, and we are good. That's all. Let's check if our code compiles. It should compile. The compiler is not complaining. Scab build. Yeah, it should compile. And that's it. We are done. So you're going to write the test for this. I feel people who have been writing smart contracts already are probably going to get more from this bootcamp than some of us who are getting introduced to blockchain dev for the first time. A lot of these concepts seem so abstract, and I'm still unsure what the real world usage of these functions look like. True. So the thing is, if you were writing Solidity, not like you will get more. Things will come in, will come in easy for those that are writing Solidity. But for those of you that this is your first encounter to the whole smart contract stuff, you have to do more practice. You understand? So, for instance, for someone who has been writing maybe a programming language like TypeScript, right? If the person comes to learn Cairo or the person comes to learn Rust, it won't be hard for the person because the person has been using TypeScript, which also has types. But if you've never written TypeScript before, all you'll be writing is JavaScript that doesn't have types. Your first encounter with a language that is using types, you're going to find it a bit difficult to sync. That is how it is. So it's something that also boils down to, okay, your experience and all of that. For instance, someone that writes Rust before can pick up any programming language and that person will be good with that programming language in 2 months. But if you've never written Rust before in your life, some programming language will be a bit confusing for you. But if you write Rust, the learning curve of Rust, once you're able to grasp Rust, there's no language you cannot learn. So you're not wrong, Hamid. So the only thing you need to do is you have to put in more work. So if those that were writing Solidity spend 2 hours in restudying, you have to spend 5 or 10 hours because this is your first encounter. So that's it. And yeah, that's all. You're going to write tests for this contract as well. So brace up, study about how to test emits and all of that. And I think I'm done for today. Any question, if you have any question? Actually, C gives you a good basis for every other language. Well, I've not written C, but I feel I write Rust and I'm looking at Go. Go is looking like a piece of cake. I'm looking at C sharp. C sharp is looking like, oh, I can eat this guy up in a month. So That's it. C doesn't give you, yeah, not for Rust, sha. Rust is a different level guy. So any question, any question, any question? You guys should leave your language argument to ask questions. It's already time. So Paul, Sarah, are you guys there? I think we are done with the class today.
Yeah, thank you so much, Casweeney. I mean, this has been quite insightful for everyone that has been attending. And we really appreciate everyone that has been joining, following up, and being active because it's pretty much not easy to be consistent for like 6 weeks thus far, right? But we still have a few weeks to go, and we encourage everyone to still turn up for the last week, which is for the live session is ending next week, Thursday. But then we have build week, which would let the active participant of this bootcamp or participant of this bootcamp build out something, and the top 3 projects would win some prizes. So we have $1,000 bounty. So if you know anyone that has been active on this bootcamp or kind of like slack back a little bit, you should let them know that we have like some prizes for the best project that comes out of this, because we are looking at, okay, what can people actually do at the end of the day aside from what the tutors has been teaching, right? Then, and for next week we would have Manoa talk about front end in integration with Starknet. So if you want to learn more about front end integration, you should of course join the last class next week, last sessions next week. Yeah, basically. Well, I know not everyone will be interested in front end, but if you know someone that is interested in front end, you should let them know to join the session next week. Then that next week as well, we're also going to make comments on how the build week is going to be, and also the graduation week. So basically for the graduation week, we're going to have someone from the foundation come share some insights. And also we're going to have Emily from Only Dust team to share solid insights on open source contribution. And as well, I just invited Elias. He's currently building one ramp. So basically, these are the people you can get insights from on how to solidify yourself in the stagnant ecosystem. But that aside, Casweeney, thank you so much for giving us 2 weeks of your time. And we hope to, of course, like keep on seeing you around as our chairman and OG.
Yeah, thank you very much. So I also wanted to like the person that won my giveaway, the person should just drop the address. Let me send the person's money before I drop from this follow. Yeah. All right. So that's it. That's Chigozim David. Can you drop your agent or Bravo's wallet? You are the one that won. I've been looking for who to give that thing since nobody read the article. So you got it today. So just drop your address. Let me quickly send you this guy before we go. We are already 3 minutes out. So sharply. Or
Yeah,
if you don't have the address now, we can end the call. Maybe you can send it in my DM. Okay, got it.
I read the article.
I I did you confirm this address? Please confirm it too. Confirm your address so that the money doesn't do OT law. All right.
okay, so if David, can you please confirm the address so we can end the class?
Oh shit. I'm still sharing. Let me stop sharing.
Yeah,
Ah, let's stop sharing again. Have I stopped sharing?
not yet.
Ah, stop sharing. Okay, stop sharing.
Yeah,
Uh,
yeah, that's okay. So David, are you there? Can you confirm if the wallet's address is cool so we can end the class?
I'm already sending it to if the wallet address is wrong.
Yeah, but then I don't think it's wrong though because the address looks long. It looks longer than
All right. Yeah, let me just do that now. Um, yep.
Yes. So for anyone looking for more rewards, don't forget to key in into the build week immediately after the bootcamp. So we're going to like share more details and insight on how it's going to be. But just know that if you're looking for like to earn your first few bucks from Starknet, this is actually going to be it because we are going to try and make the prize pool to be quite interesting for the top the first position, second position, and the third position. So it's going to be quite interesting. So that's all
Okay.
for this
All
week.
right. Maybe I received it. Right.
Awesome.
All
Yeah.
right.
So that's all for this week and good night everyone.
Bye, everyone.
Yeah, bye.